use a linear approximation to estimate square root of 4.99 to the power 2 minus 3.01 to the power 2. I can see that in my grade school setting, I would think about square root of 5 to the power 2 minus 3 to the power 2. And so just let's use that one, right? And so what happens is basically I will end up with f of x and y to be two different variables, right? I changed that and I changed that. Could be more than two, but right now we have two variables. And then so if I evaluate at 5 and 3, I will end up with 4. And the partial with respect to x of this thing is going to be 2x over 2 square root of x squared minus y squared, which is x over square root of x squared plus minus y squared, and f sub y of x and y. And similarly, minus y over x squared minus y squared. And if I plug in, basically what you want to do is plug in the nice values in there, because you're finding tangent plane or linearization at 5 and 3. And so that would give you 5 and 3, 5 and 3, and that the first one gives you 5 over 4, the second one gives you negative 3 over 4. And so this basically gives you the gradient vector for let's write this down. So if I write everything on one side, or I can use the fact that it's z minus x squared minus y squared equal to 0, and so, or the other way around, x squared minus y squared minus z equal to 0. So the gradient vector of this, which is the f of x and y and z, is going to be the same thing for f sub x, 5/4, the same thing for f sub y, negative 3/4, and negative 1. And so if I dot this with x minus 5, y minus 3, and z minus 4, and set that equal to 0, I get the tangent plane basically. That would be 5/4 of x minus 5 minus 3/4 of y minus 3 minus z minus 4 equal to 0. And I can take minus z to the other side, keep the 4 over here, and I get z is equal to 4 plus 5/4 of x minus 5 minus 3/4 of y minus 3. This is basically delta x. What is delta x? We're trying to evaluate at 4.99, and the other one is delta y, and delta y is 0.01. So delta x is negative 0.01, and y is, so this is negative 0.01, and this one is positive 0.01. And if you evaluate, you end up with 3.8. And that's the linear approximation of the basically square root of 499 minus 3.001 to the power 2.